Good afternoon, student. So welcome back to Mr. Chen's Master Channel, Master Class. So this one, and I would like to talk about Chapter 7 from the James Stewart textbook. It's all about the trig identity. So today we just want to start out with the lesson on 7.1. And you probably see that this one is 5.1. It's a different textbook that I generate with those type of practice problem. So this one's supposed to be section 7.1 from that James Stewart pre-calc textbook, the 5th edition. And the following problems simplify each expression to its lowest term, and then write the answer in part B as the product of factors. Okay, so now let's just put it out. Okay, so just want to put into the new space here. Okay, so we do have different level A, B, and C. Okay, so you're probably wondering from the basic one, medium, to the challenging one. Yeah, indeed. Okay, so now let's see. So for A, we do have sine of x minus cosecant of x. And then the whole quantity, it's divided by cotangent of x. So first thing that you want to do, so you don't see any kind of Pythagorean identity, so you can always rewrite this one as sine and cosine. So rewrite everything in terms of sine and cosine. Okay, so cosecant is 1 over sine. And then cotangent is cosine over sine. And now you might be wondering, it's a complex fractions. So what can we do with the complex fractions? We always want to multiply the LCD for the complex fractions. So the strategy is called rationalizing. So multiply the LCD. So we do have sine of x multiplied by sine of x, top and the bottom. Okay, so multiplied by sine of x. And then this one here on the top, distribute. So we do have sine square of x minus 1, because 1 over sine times sine of x, it's just 1. And then denominator, cross cancel, so we do have cosine of x. So now you might be wondering, what's sine square of x minus 1? Isn't that considered negative cosine square of x? It is. And why is that? Because that cosine square of x plus sine square of x equals negative 1, equals positive 1. And then once you put in that sine square of x minus 1, so that's the same as negative cosine square of x. Divide it, so we do have negative cosine of x. Simplest form. And now, what about for b? So this letter here, so that looks kind of, weird. So this one is the Greek letter. It's called sigma. So you might be wondering, is that a summation notation? So that's just the way to pronounce it. Yeah, so that's the way to write sigma in the Greek letter form. So normally this one we need to generate, the sum of the entire sequence. So now check it out. So 1 sine of sigma plus cosine of sigma, and then quantity square. So this one you can always regroup them. So let's put it in this way before we expand it. So this one is just like 1 plus x quantity square. So it's 1 square plus 2 times sigma, sine of sigma, plus cosine of sigma, and then plus sine of sigma, plus cosine of sigma, quantity square. Okay, so that's just like the binomial, perfect squared binomial, or the binomial expansion. And now this one you want to distribute, expand it, so it's 1 plus 2 sine of sigma, plus 2 cosine of sigma, and then plus sine square of sigma, plus 2 sine sigma, cosine sigma, plus cosine square of sigma. And then for this one, so things that we can combine the like term, we try to combine the like term. And it looks like this one, we can combine this together, so that's 1. So 1 plus 1, 2. And then the rest of this, we do have 2 plus 2 sine sigma, plus 2 cosine sigma, and then plus 2 sine sigma, cosine sigma. And now for those you might be wondering what we can do next, well, this one can factor by grouping. So factor by grouping, take out the greatest common factor, so take out 2. So we do have 1 plus sine of sigma, And then the second group here, so take out 2 cosine of sigma. So we do have 1 plus sine of sigma. And then, so this one, just take out the common binomial. So 1 sine sigma. And then, well, the 2, also we can put it out. So 1 plus cosine sigma. So this one would be the simplest factor form. Alright. And now, what about for C? Okay, so let's check it out for C. Okay, so now let me just clear all the annotation. Okay, so now for C, this one looks a little bit hectic. So it looks like we do have a quadratic inside a quantity. So tangent of 2x squared, secant of 2x squared. So the way to simplify this part here, I mean, the thing about the way that we can rewrite it in terms of cosine and sine, certainly we can do that. And for those you might be wondering, can we apply the Pythagorean identity? So got to be careful. This one, it's not the quadratic. It's not tangent square or secant square. It's tangent of the quantity 2 times x squared. Secant of the quantity 2 times x squared. So there's no way you can apply the Pythagorean identity. So now let's just put it in this way. So for 2x squared, so if that's kind of confusing, you can always set up the substitution. So let u equals 2x squared. So let's just rewrite it as 1 over tangent of u and then minus secant of u. So let's put it that way. And then tangent is secant. We can always rewrite it as sine over cosine. So it's 1 over sine of u over cosine of u minus 1 over cosine of u. And using the same kind of strategy as what we did for A, rationalize it. So multiply the top and the bottom by cosine of u. The least common denominator. Again, the strategy, it's called rationalizing. So on top of that, so it's straight across, cosine of u. Denominator, distribute, we do have sine of u minus 1. And now you might be wondering, is this the simplest form? Anything else that we can do? Yeah, certainly we can simplify it a little bit more. So this one, we want to multiply, keep rationalizing it. So multiply the conjugate of the denominator. So it's because that's a binomial. So another rationalizing technique. The conjugate, denominator, so sine of u, and then plus 1. So sine of u plus 1. So what we found here, we got cosine of u times, now you don't want to distribute this one yet, so just keep it that way. Denominator turns out to be sine square of u minus 1. And you may notice that for A, we did it already, so that one is like negative cosine square of u. Okay, by using the Pythagorean identity. Reduce, reduce. So what we found here, so it's sine of u plus 1 over negative cosine of u. And then you try to plug everything. So u, what is that? 2x squared. So sine of 2x squared minus 1. Actually plus 1, excuse me. And then all over negative cosine of 2x squared. Okay, it is a little bit complicated because we have to rationalize it twice. Okay, so now back to the template. Let's see what else that we got right here. So number 2, so that's just like using the bunch of substitution. Okay, so we'll do 2a and b. Okay, so check that right here. So for 2a, so evaluate, so x squared times square root of x squared plus 81, where x equals 9 times tangent of theta. So started with the substitution here. So x, which is 9 tangent of theta, quantity squared, and then square root of what? 9 tangent of theta, quantity squared, plus 81. Okay, so started with the direct substitution, and then distribute. So 81 tangent square of theta. And then this one here is also 81 tangent square of theta plus 81. And now for the radical, so you probably don't want to just leave it like that because that's not the simplest form. So carry this one down. So inside the radical, you want to take out the greatest common factor, 81. So now what's left here? It's the quantity of tangent square of theta plus 1. And one thing that we notice, this whole thing here, it's just considered 9 times secant of theta. Well, secant square of theta, but take the square root of that, it's just secant of theta. So 9 times secant of theta. Okay, so now what we got here, so 81 times tangent square of theta, so which is what? Sine over cosine. Or basically you can just leave it like that, because nothing we can reduce here. And let's see what else that we can do. So 81 times 9, then that'll be 819. Well, no, excuse me. Sorry. 729. So times tangent square of theta times secant of theta. Okay, so just keep it that way. Because tangent is written as sine over cosine. Secant, it's 1 over cosine, so nothing we can cross cancel. So keep it that way. And now, what about for the other one? So this one's quite similar. So it's 4 minus, so 2 sine of theta, quantity square. And then the whole quantity to the power of 3 half. So 4 minus 4 sine square of theta. So take out 4 here. So we got 1 minus sine square of theta. Again, they're all under the same power. So this one is basically written as 4 times cosine square of theta to the power of 3 half. So 4 to the power of 3 half, so just like square root of 4, which is 2 times 2 times 2, so 2 to the power of 3, 8. And then cosine square of theta to the power of 3 half, which is cosine of theta to the power of 3. Okay? Just like that. So it looks kind of complicated with the problem, but once you plug in a number, try to find a way to simplify it using the algebraic technique, and also at the same time the identity, Pythagorean identity. So it's actually pretty straightforward. And now let's see what else. And number 3, that one you want to prove, verify. So square root of, okay, let's just put it out first. Okay, so let's see what that is. Okay, so anytime that you want to prove, you always want to verify the one with the most complicated side. But at the same time, you'll see that if both sides are kind of complicated, so you have to verify both sides. Okay? So that one is just a square root. Okay, so start out with the left-hand side. So this one, if you just pull the radical, separate it. So square root of 1 minus cosine of x. Okay, so top and the bottom. And then the right-hand side, what we got is cosecant. So this one can be written as 1 over sine of x minus cosine of x over sine of x. So again, we need to verify, so try to simplify both sides here. So on the right hand side, so this one is absolute value of 1 minus cosine of x over sine of x. Okay, so making sure that this one is all positive. So nothing we can do, so just keep it that way. But now what about the left hand side? The left hand side looks like we need to rationalize it. Multiply the same radical, top and the bottom. Not the conjugate, the same radical, because you want to get rid of the radical. So multiply by 1 plus cosine of x, square root of 1 plus cosine of x. So denominator turns out to be 1 plus cosine of x. And then the numerator, it turns out to be square root of 1 minus cosine square of x. Because once you multiply this out, it's a difference of 2 square. And one thing that we notice, using the identity, so this one, okay, so difference of 2 squares. And then the rest of this, which is the Pythagorean identity. It's the same as sine of x over 1 plus cosine of x. And you might be wondering, wait a minute, the left-hand side, it's not the same as the right-hand side. So one more thing that we need to do, rationalize. So this time we need to multiply by the conjugate of the denominator, top and the bottom. Okay, so this time the conjugate. So which is 1 minus cosine of x, 1 minus cosine of x. So now, without multiplying this out, so this one, just keep it. So it's just 1 minus cosine of x times the sine of x. Denominator, difference of 2 square. So 1 minus cosine square of x. Which is the same as what? Sine of x. So we got 1 minus cosine of x. Like that. And it looks like this one is the most simplest form, but somehow, what about, oh, you know what? We left with sine of x. We don't just cancel out that. Because sine square of x, sine of x, reduce. So it's 1 over sine of x. So absolute value, it makes sure that this one is all positive. Once you take the radical, top and the bottom, they always consider positive. Okay? Because that, if it's negative, that means it's all considered imaginary number, if the quantity inside. Okay, so positive, positive. Okay, ditto. Again, absolute value, it guarantees that it's always positive. Okay, so now, let's see what else. Back to the template. So number 4, that's something you guys can finish. So it's all about the substitution. So try to isolate that cosine of x, and then solve it in terms of the other form, and then you want to put into that for the second expression or the equation here. Okay, what about something like number 5? Again, that one is quite similar to what we did. It's about finding the least common denominator. But we can take a look at that. Okay, so number 5. So quite similar to the one that we've been doing. So again, find the LCD. Excuse me. So this one LCD, then that we consider 1 minus sine of theta times 1 plus sine of theta. Things that, if they don't have anything in common. So 1 minus sine of theta. So 1 plus sine of theta. So anything that's missing top and the bottom, you want to multiply it. So this one you multiply by 1 plus sine theta. This one here, multiply by 1 minus sine theta. So what we got here is just consider 2 all over 1 minus sine theta, 1 plus sine theta. So once you multiply them straight across, so this one is considered 1 minus sine square of theta, which is 2 over cosine square of theta. So eventually it's 2 secant square of theta. Okay, so it's relatively easy. Okay, so now let's see what else. So what about something that's considered challenging? Like this one right here. Okay, we'll look at that. So verify sine of x plus cosine of x over sine x minus cosine x plus the opposite. Okay, so that equals the negative 2 over cosine square of x minus sine square of x. Okay, so let's put it right here. So this one looks kind of silly. And it looks like the right hand side is the simplest form. And you might be wondering, well, this one can apply to double angle identity. Yeah, certainly we can do that, but just keep it that way first. Okay? So try to use the double angle identity. This one, the right hand side could be simplified into negative 2 over cosine of 2x. But just save the double angle. We'll talk about that later in one of the sections for this unit. Okay, so just keep it as that way. So negative 2 all over cosine square of x minus sine square of x. So again, the left hand side, the right hand side. So what we need to do, just rationalize it. So once you rationalize it, you'll find out things that we can cancel. So for the first rational expression, so you just need to multiply by the conjugate of the denominator. There's no radical involved, so just multiply by the conjugate, not the radical. So sine of x plus cosine of x. And then, what about for the other one? So similar, multiply by the conjugate, which is sine x minus cosine x. Okay, I'm going to rewrite this part here. Just like that. And then one thing that we find out, the top part, is just the binomial expansion. So sine square of x plus 2 sine x cosine of x. And then plus cosine square of x. Denominator, the difference of 2 square. So sine square of x minus cosine square of x, which is considered negative 1. Okay, so the other one too. So check that. So this one right here, it's always considered negative 1. Okay, because once you bring this one all the way, well, let's see. Wait a minute, it's not negative 1. We do know that sine square of x plus cosine square of x, it's 1. But sine square of x minus cosine square of x, okay, just keep it that way first. Well, that's what we need for the denominator eventually. So just keep it that way. Okay, so sine square of x minus cosine square of x. And then this one right here, similar. So sine square of x minus cosine square of x. The top part right there, binomial expansion. So sine square of x minus 2 sine x cosine x plus cosine square of x. And what do you notice? If you just combine all this together, so this one is just like 1. Here's another 1, because that's the Pythagorean identity. So then that turns out to be 2. And then 2 sine x cosine x, it cancels out with negative 2 sine x cosine x. So what we found here, it's just 2 over, so sine square of x minus cosine square of x. Now, it's almost the same as this. Another thing that we need to do, we swap the terms. So once you swap the terms, you get 2 all over negative 1 times the quantity, cosine square of x minus sine square of x. So take out that negative 1 as the greatest common factor. So eventually, you'll end up with the exact same thing. So just bring that down, ditto. Okay. So again, this one is nothing new, nothing special. It's something that we did in trig last year. You know, for those students who took my class last year for trig honors. So we did something similar to this. But this one is definitely a lot more rigorous. Okay, so now let's see what else that we got for this section. And then the other one, just factors, simplifying. So that's something you guys can finish. So one thing I would like to talk about is that 8 and 8, 9, and 10. Okay, so let me just take those. Okay, once again, one problem at a time. So for that section 7.1, I really want to break into two parts. So the one is the first half, which is just the introductions of going back to the Pythagorean identity and some of the basic identity, so that we can apply for verifying. So if the sum of the angles of a triangle, it's x, y, and z, okay, it's pi. Well, that's just the triangle sum theorem. Okay, so triangle, x, y, and z. Okay, so the sum is pi. And then simplified expression, secant x times sine of y plus z. Okay, so you guys do remember that the cofunction identity. So y plus z, what is that equal to? So y plus z is just considered pi minus x. Okay, so this one can be written as secant of x times sine of pi minus x. Okay, so secant is considered 1 over cosine. And we do know that pi minus x, so that's just in the second quadrant. Doesn't matter what x is. So x is what? This one is less than 180. So this one is going to be either in quadrant 1 or quadrant 2. So for pi minus x. Okay, so it doesn't matter where x that is. It could be right here, or it could be all the way over here. Because that's going to be less than pi due to the triangle sum theorem. So this one is the same as what? It's the same as the ratios of sine of x. Okay, so this one is the same as the ratios of sine of x. And guess what that is? So this one eventually is going to be considered tangent of x. So kind of interesting, huh? Okay, so again, what I did here, using that, the triangle sum theorem for the substitution for that y plus z, and then just analyze it. So sine of pi minus x, it's the same as the ratios of that sine of x. Okay, so sine of x over cosine of x, tangent of x. Okay, so that's number 8. And let's see what else. And what about number 9? Which of the following statement is or are true? Explain. So again, this one is about verifying. So one thing that we talked about before, anytime that you take the square root of the whole quantity, it's always considered the absolute value of the whole quantity. So if you see anything like this, that means consider the absolute value of the whole quantity. So one thing that we notice, if you try to expand it, so this one, it's always considered positive value because the square. Okay, so once you take the square, you make sure that the whole quantity, the value is positive, and then you take the square root of the positive number, you always guarantee that it's positive if that's solving for the equation. And this one here, the right hand side, it doesn't show the absolute value symbol. So this one is saying that it's just being negative, okay? But also this one, it makes sure that if you see anything radical with the square root, it's always considered positive. So in order to make sure that it's positive on the right hand side, so we need to put in the absolute value. Okay, so this one, no, but this one, yes. So this one is not true, but this one, yes. It's always true. And now let's see. Number 10. So find the value of cosine of 70 degrees plus cosine of 110. So let's put in the analysis. Cosine of 110. 110 is over here. Should be a little bit over back to the right. Okay, so the diagram is not drawn to scale. So this one is the same as the ratios of cosine of the reference angle, which is 180 minus 110, so then that'll be 70. So it's the same as negative cosine of 70 degrees. So same as cosine of 110. Okay, so this one's minus cosine of 70 degrees. So negative, positive, negative, cosine of 70 minus cosine of 70, 0. Just like that. So it's pretty easy. Okay, so stay tuned. So for the next section, it's going to be the second half of 7.1. So we'll talk about that later. Okay? So there are only a few problems there. We'll talk about that in the next part of the video. Okay? So thank you for watching it. If you do like it, make sure that you subscribe to the channel. So I'll see you guys next time. So you guys have a great one.